In this video, we are going to show you a simple demonstration of a detention pond using drainage in OpenRoads Designer. Now, while we won't be going through every single step on how to create the detention pond, hopefully after this video you'll be able to use the tools and methods that we have set up in order to possibly analyze a detention basin that you may get, or if you have a detention pond or a detention basin with your project, you'll understand how the tools work and you can apply those accordingly. So with that, let me go ahead and demonstrate this particular setup. And basically what we have here is a 36-inch pipe and a 48-inch pipe coming into this detention pond, and then we have an outlet structure right here. So if I go up to one of these right here, and I'll go to this node and get to the dynamic toolbar, I will go to the utility properties. The first thing that we're going to set up is the water coming into it. Now whenever you're doing a detention pond, what you need to do is actually set up what they call a hydrograph. So in order to do that, we have to go to the inflow wet collection, and inside of here we're going to click this button, and in order to create a hydrograph load, what you would do is come up here and click on new and do the hydrograph load. Now this is something as you as a designer would have to set this up to determine how much water is coming into it at a certain time. That way you can analyze that pond properly, depending on how full you want it to get it, or how much water is going into it and stuff like that for analyzing it. So that's something that you would have to set up for that water that's coming into that node. And for this simple example here, I just went through and set up at 0 hours. Of course there's no flow going into it, and at 1 hour this much flow is coming into it. At hour number 2 it's got this much, and then it trickles down from there. So that's what I have set up for this particular inlet. Now if I go to the other side and I would select this node, and I got the same setup for that one for the inflow collection. And on this hydrograph load, you see that I have 1, 2, 3, 4, 5, 6, and 7, and then of course these flows coming into it at that certain point. That way it'll analyze that pond correctly. Next thing that we're going to look at is our outlet structure right here. And whenever I place that, I actually use the place node tool, and inside of here you'll see that we have a section called Pond Outlet Control Structures, and this is where you can come through there and select whichever control structure that you're using for the outfall for that particular pond or detention basin. Now on this one here, you'll notice that my outlet structure is set to Weir rectangle, and we'll come back to that here in a second. Another thing that we have to set up for this right here is what pond structure is coming into it. So what we have to do is, whenever you want this pond to be associated with this node, you have to select it and then come in here and basically tell it which upstream pond that you want. So you'd come in here and select upstream pond and then select outside boundary of it, and then it would be associated to it. And then of course it has a controlled structure, which is yes on that, and then whatever controlled structure that you want. Now if you need to change that for whatever reason, you can come in here and actually select that option and go to your down arrow, and you could define a different outfall structure that you wanted. You can define a different outlet structure if you wanted to. You can also come up to your edit composite outlet structure, and this will allow you to edit how big that structure is going to be. And to show you that, we'll click on that. This is where you'd come in here, and like for this example here, our outlet structure is set to Weir rectangle. We would come in here and actually select the one down below there, and this is where you would come through here and set up, how big it is, what elevation it is, and so forth. And this is something as you as a designer would have to look through these settings to get it set up properly. For like this one here, we have it set up to where the elevation of it is at 95, and then of course my weir length, basically what width that opening is going to be, is set to 2 feet. So whenever I come through here and I actually do a compute rating curve on it, it gives me this rating curve. So at elevation 95, which is actually the ground elevation for that pond, which I'll show you here in a second, that there is 0, so there's no flow going into it. But as the water starts to get deeper through there, you'll notice that this is how much flow is going to get through there, depending on what elevation that you have it. So if I come in here and I change that to something a little bit different, maybe my weird length is 4, and then I recompute it, you'll see that these are going to look a little bit different. Let me go ahead and change that back to 2, and I'll hit tab. Of course, right now, since it got wider, of course my cubic flow is going to get a lot bigger. But now since I'm going to shrink it back down to 2 and I recompute it, you see that it gets smaller because of course my opening is a lot smaller. So that's just something that you would have to look at depending on which outlet structure that you have. You'd have to go through there and set that up accordingly. That way it'll compute it correctly. So once we have that set, we're going to leave our opening set to 2 feet and the elevation of where it starts at is at 95. We can close it down. Another thing that we're going to have to look at is our pond. So I will go ahead and select it. And on this one here, you have to basically set up what size that you want your pond to be. Now for your volume types, you have different options, and this is stuff that you can look at depending on what function that you want to use. But for this example here, we just used an elevation area. And then you can come in here to your collections. You will see for this example that at elevation 95, it covers this many acres. And then at elevation 100, it's at this many acres. So we have a little bit of a taper going down the side of that particular pond, but that's just something that you would have to determine how big your pond is going to be, maybe at certain elevations, or if you want to use a different volume type, you can come in here and change that volume type to something different. So if you had an elevation volume, you can come in here and basically define at elevation, it holds this many gallons. All right, another elevation, it holds this many. So there's different types that you can use, but the one that we're going to use for this example is the elevation area. So now what we need to do, we're going to look at these outlet structures for the water coming into the pond. So I will select this one. I'll go to my utility properties. And what we have to do on this right here is make sure our boundary type is set to boundary element. Because normally whenever you set this, it's going to be set to free outfall. So in order for this to compute properly, once you have those structures set, you'll need to change that to boundary element. And previously it was set to free outfall. You'd set that to boundary element, and then you'd come in here and define what your boundary element is, which of course would be the pond. So you'd come in here and do select boundary, and it says select from drawing, and you select the pond, and then that'll be set accordingly. And then you do the same thing for this structure right here. Because if you don't, then it doesn't know where that water is going to go to. So that's another thing that you have to look at. So that's what we have set up for this particular detention pond or detention basin. Now let's go ahead and actually analyze this particular detention basin. In order to do that, we're going to have to activate a different license in order for it to compute properly. And the license that we're going to have to activate is what they call CivilStorm. So I will close that down, and I will go to the Tools pull down, and you have 4 licenses that you can pull from right here. In order to do a detention pond, you have to select the one that says CivilStorm. So we will select it. And we have a few licenses here at MoDOT. So whenever you select that, it should automatically go to it. And the reason why we have to change this is normally whenever we're doing stormwater drainage, we use the rational method to do peak runoff flow for like your inlets and stuff like that. Well, in order to do the analysis for a detention pond, we have to use a different solver. And in order to use that different solver, which is going to be a swim solver versus the rational method, you have to activate the CivilStorm license to do that. So once we have that set, we're going to go ahead and go back to our analysis. And first thing that we're going to have to do is actually set up a different analysis for it. So we'll go to Analysis, Options, and by default we have a base analysis and a base design. The analysis just analyzes your drainage scenario, and then the design will actually design it where it adjusts elevations and change pipe size and stuff like that. Well, we need to actually create a different solver for this. So we will go ahead and do a new, and you'll see new solver. And I'm going to go ahead and rename that to SWIM, which is SWMM. Once we have that set, I will go ahead and right click over it and go to Properties. And in here's where we're going to have to go ahead and change what that solver is. Where it says Active Numerical Solver, we're going to go ahead and change that to SWIM Solvers. And this is where you'd go through here as an engineer. You may have to come through here and look at all these different attributes. We're just going to use the defaults for this example, but this is something that you would have to look at to make sure everything's set correctly. Say, for example, you're looking at a duration of 24 hours. You just leave that set, but maybe you're looking for a duration of 48 hours. You come in here and change that solver to that right there. So that's stuff that you'd have to look at as a designer and change those accordingly. Now that we have the solver created, now we're going to go ahead and create a scenario for it. So let's go ahead and select Scenarios, and we're going to go ahead and use the Central Design. And for this one right here, we're going to use this option right here, but we're going to make a child of this particular situation. So we'll go ahead and right click over the base analysis 100 year, and we're going to do New, but we're going to do a child scenario. So basically what it's going to do is take on all the attributes that's set up for that particular scenario, but it's going to make a child of it. We'll just name it SWIM, SWMM, and I will right click over it and go to Properties, and you'll notice that it takes on all the attributes for that, but our solver here, this is where we have to change it to that SWIM solver that we just created from the options. So basically it's looking at, it's inheriting everything that's set up for this option right here, which is that 100-year event, but we're changing the actual solver for it, for the SWIM analysis. So once we have that set, we are good. We can go ahead and close that down. Now we can go ahead and try to compute this particular drainage pond that we have set up. So let's go ahead and go to the Compute Center, and we will change our option from this analysis 100-year event. We're going to change it to that SWIM option that we just created. Now we can come through here and compute it. So I would just select this option right here that says Compute, and it goes through there and analyzes everything. Now we do have a couple user notifications that you may have to look at, but it had enough information for it to do the computations for it. So this is where you come in here and actually look and see what it's doing. If I go to the nodes, you see that you have this information of what it's doing. You got your links, you got your catchment, you got your pond, your storage. You can see that it's at max full, it's at 84% basically, and how long it's at max storage. So stuff that you can look at to see if pond is sized correctly, or if it's not sized correctly. Maybe it needs to be a little bit bigger, maybe it needs to be a little bit smaller. Maybe your outlet structure needs to be a little bit different than what you have designed. So this is stuff that you'd start to look at as a designer and determine what needs to be changed, or if everything looks good, you can just leave it as is. So I'll go ahead and close this information down. Next thing that I'm going to show you is we're going to look at a graph for that pond. So I'm going to select that particular pond and get to my dynamic toolbar, and the second icon you can do an option for a graph. And for my graph here, I'm just going to graph that hydraulic grade line for that pond. So I'm not going to change any of my settings here. If you want to experiment looking at some other stuff, you can, but I'm just using the defaults as it is for right now. And you'll notice for this particular situation, you see that I have my pond, and basically at whatever hours, this is how full that pond is going to be. So basically right around 4 hours it's going to be max full, and then it's going to start to trickle down from there because I don't have that much inflow coming into it. So it's all trickling down because it's still going through that outlet that I have defined down below here. So you can kind of see what's going on. Another thing that you can do is or what they call a time browser, where you can play it and you can kind of see how much water is going through there at certain times if you want to utilize that. Now, the thing that you can do is you can actually add the inflows coming into it. So in order to do that, maybe add that to the graph. Let me go ahead and resize this for the time being. And I will select this option right here that says add to graph. And maybe I want to add this one and this one, because that's the inflow coming into the particular pond. And I will go ahead and click on the check mark to accept it. And you can see right here, this is the inflows coming into it. You may find that useful, you may not, but you can actually add that to the graph also and kind of see what's going on at particular points, throughout your pond or your detention basin that you're trying to design or to analyze. I will go ahead and close it down. Another item that you may find useful is the profile runs for it. So you may want to look at the profile run for this particular pipe or this particular pipe, or maybe this ditch that's going down through here. And that's what's defined for the outfall, is actually a 2-foot flat bottom ditch. So let me go ahead and go to layout, and I will do utility runs. Select my profile run, and I'll just name it 36-inch pipe, and you can name these however you want. Select that, and I will right click over it. And for the second one, I will go back to utility run. Go ahead and change this. Right click to finish, and then I'll do the third one. Now that I have those 3 created, I will go to the Project Explorer, go to Drainage and Utility Models, and I will expand this down. And you see that I have my 3 profile runs underneath there. And of course you can name these however you wish. I just named the first one 36-inch pipe, and then of course this other one is profile run and profile run 1. Like I said, you can name those however you wish. I can come in here and rename this one. I'll just rename it to ditch, and I'll rename this other one to 48-inch pipe. Well, what I can do now is come over here and right click over it and do Open Analysis Profile. So for like this one right here, which would be this pipe, I can come through here and see how much water is coming through that pipe at a certain point. So if I come in here and I use my time browser, which is this right here, you can see how much water is coming into this pipe at certain times. And you'll notice as it goes through there, you see the water starts to trickle down. So it all depends on how you set up your hydrograph. Of course, this time browser will be set up with that accordingly. Same thing for the 48-inch pipe, and then also my ditch. Let me go ahead and analyze that ditch. And you'll notice as it goes through there, it's going to adjust at different elevations. So basically right around hour number 4, that's whenever it's going to be at its peak for that particular situation. And then after that it starts to trickle down because no more water is coming into here, but water is still coming out of here because you have a pond that's of course storing that water. So this will slowly go down as time goes on, and it'll trickle out of the pond accordingly. Let me go ahead and close that down. So that's just some general information on how to set up a detention pond in drainage using the OpenRoads Designer Connect Edition. Now, if you need additional information on creating a detention pond or detention basin, feel free to call CAD support and we'll be more than willing to help you out.